Welcome to the presentation on the basics of aircraft structures. In this session, we will explore the fundamental components and materials that make modern aircraft safe, reliable, and efficient. Why understanding aircraft structure is crucial? Understanding aircraft structure is essential for three main reasons. First, it ensures airworthiness by meeting safety and operational standards. Second one, it helps prevent structural failures by understanding design limits. And the third one, it optimizes maintenance by enabling precise inspection and repairs, extending the aircraft's lifespan. The grand design primary structural components. The primary components of any aircraft structure include first one, the fuselage, which is the main body housing the cockpit, passengers, and cargo. And the second one is wings, which generate lift, store fuel, and often house landing gear. And the third one is the empennage or tail section, which provides stability and directional control during flight. Fuselage construction, monocoque and semi-monocoque. The fuselage can be built using two main methods. Monocoque construction, where the outer skin bears most of the structural load. This method is lightweight but can be vulnerable to buckling. Semi-monocoque construction, where the skin is reinforced with internal frames and stringers, providing superior strength and damage tolerance. This is the most common method in modern aircraft. Wings, spars, ribs, and skin. Wings are made up of three major elements. Spars, the main load bearing members that resist bending forces. Ribs, which define the wing's shape and transfer aerodynamic loads to the spars. Skin, the outer covering that provides rigidity and forms the aerodynamic surface. Empennage and control surfaces. The empennage or tail assembly includes the vertical stabilizer with the rudder, which controls yaw or left-right movement. The horizontal stabilizer with the elevator, which controls pitch or up and down motion. Additionally, ailerons on the wings control roll, allowing the aircraft to bank during turns. Materials matter. Aircrafts are built with materials that balance strength and weight. Aluminium alloys have been the traditional choice due to their excellent strength to weight ratio and corrosion resistance. Carbon fiber composites are now widely used because they are lighter and stronger, reducing fuel consumption. Titanium alloys are used in high stress areas like engine mounts and landing gears, thanks to their strength and heat resistance. Key takeaways. In summary, aircraft structures balance strength, weight, and aerodynamics to ensure safe flight. The fuselage, wings, and empennage form the foundation of aircraft design. Material advancement like composites and titanium are pushing the boundaries of safety and efficiency in aviation. Thank you for your attention. Understanding aircraft structures is key for engineers, pilots, and aviation professionals to appreciate how every parts work together to keep aircraft airborne. Thank you.